So thank you for having me, and it's my pleasure to be here. So I'm a professor at San Jose State. I'm going to just, my talk will be a little bit different. I think actually all the talks are a little different, which makes it interesting. I'm just going to tell you kind of about my career trajectory and some of the things that I've kind of learned along the way that have been at least helpful for me. So here's a picture of me. I'm a doctor. I am have a PhD, but some people know me as Dr. Burrito. And I'm going to kind of share with you a little bit about how that happened. So it started at Cal State Northridge. I was a physics major and interested in science. But I was in a public speaking class, and I had to give my final talk. And so I ended up showing this chemical reaction. And this is chlorine plus ozone producing other chemicals here, chlorine monoxide plus oxygen. But the chlorine monoxide can react with oxygen, which is around all over the place, to reproduce this chlorine atom here. And then that chlorine can go back and react with another ozone molecule. And this is a catalytic cycle that can happen, and many of you are very familiar with this, can happen over and over again. And what I found interesting in this is that one chlorine atom can actually destroy or convert like hundreds of thousands of ozone molecules. And this was something that was well known. But what was not so well known or understood was that the amount of ozone on our planet, and this blue denotes kind of low ozone values, can happen. And this is an unintended consequence of anthropogenic or human-produced chemicals. And so when this was discovered, and this is a NASA satellite image of the ozone hole, the scientists at NASA were like pretty shocked. Like they thought there was going to be slow ozone loss in the upper atmosphere. They didn't expect a hole in the ozone layer. And this was one of the first times that we realized that humans can have a real impact on our planet. And this impacted me as well. I'll fast forward to some results from a colleague of mine. This guy's, probably some of you have heard of Paul Newman. This is another Paul Newman. This is an ozone scientist at NASA, Paul Newman. And him and his colleagues wrote this, did this analysis. And first they show you how the ozone levels have changed from the 1960s into the year 2000. Ozone levels have been declining. The good news is the projections for how ozone is going to change in the future is that ozone levels are going to recover. And the reason they're going to recover is that scientists like us said, hey, this is happening. Policymakers took steps to phase out ozone-depleting chemicals. And the projections for the future are that the ozone layer is going to recover. But they had a fancy chemistry climate model where they ran these simulations that said, what if we didn't pay attention to the science? What if we said that it was a hoax? What if we said we're not going to change our policy and phase out ozone-depleting chemicals, and we just ignore the issue? And this is how ozone levels would have changed in the future if we didn't pay any attention to the science. And this is what they call the future world that we avoided. So by 2050, we could have lost more than half of our ozone layer. Now, what would that mean? Well, there's a thing called UV index. It tells you how much ultraviolet radiation is coming from the sun. In the summertime, when it gets into the extreme level, it's above 10. That means your skin can burn in a relatively short period of time. In this world that we fortunately have avoided, we could have UV indexes up to 30. So what would that be like? By 2050, an average skin could have been burned in less than 5 minutes. That might look like this, or like this. And we might have to live like this. So fortunately, that didn't happen. And so this very thin layer of atmosphere that surrounds our planet and real small amounts of ozone turn out to be really important. And so one of the things that I learned, and I did research at NASA, at the Goddard Space Flight Center with this group of about 90 scientists who are studying ozone. I also did that in Australia. But one thing, kind of a simple thing I learned, is that small things can be important. A small amount of this chemical, this chlorine, can actually have a big impact on our planet. Now, sometimes small things don't matter, and I like to demonstrate in my class. Like if you have some coffee there, right? if I just put a tiny amount of something in there, would it matter? Like if it was cyanide, just a tiny amount, right? Sometimes small things do matter. And that's a great thing about science, is we try to figure those kind of things out. Now, the issue that I've been involved in the last 10 or 15 years is about climate change. And you've probably seen the record of how temperatures have been changing on our planet. In fact, 2016 was the warmest year on record. The second warmest year on record was 2015, and then 2014. It's not a regular path, but since most of us have been alive, the temperature of our planet has been steadily going up. And so this has been the area of my particular interest. And then we've probably seen these kind of images of glaciers. This is one in 1918 in Svalbard, Norway. And this is a more recent depiction. We see the amount of ice going down on the planet. Here's another one in northern Alaska of a giant. You can see this large glacier. And then today, although what I found interesting about this is that this small iceberg right here seemed to have resisted over 100 years of warming. That's right, that is a joke. But here's the Arctic sea ice extent that I downloaded yesterday. This is the amount of sea ice over the Arctic, and usually it goes up like it does in the wintertime, December, January, February. Here we are today. And this year has been exceptionally warm in the Arctic. In fact, we are witnessing the decline of sea ice in the Arctic. And it kind of acts like a cooler for our planet. Like this is where, this is an area that keeps our planet relatively, this is a cool area. And now we're seeing that the amount of ice over this area is declining very rapidly. And it's kind of challenging or scary. Here's the big challenge in terms of climate change. I mean, we could talk about this for a while, but my interest kind of stemmed in a diagram like this. So it's kind of a simple story. Since 1850, we took fossil fuels out of the ground and we burned them to drive the Industrial Revolution, to basically produce almost everything in this room and all the energy that we benefit from. And that put about 1,500 gigatons of carbon into the atmosphere. Our goal, the United Nations goal, is to try to keep the temperature below 2 degrees Celsius warming. And we think that we can kind of deal with that. Anything above that adds additional risk for the 7 to 10 billion people on the planet. So how much more carbon can we put into the atmosphere? The estimate is about 500 gigatons of additional carbon can go in there. And the challenge really is that there's about at least 3,000 gigatons of carbon in the ground. So if we put all that carbon in the atmosphere, we're going to be way over the 2 degrees Celsius. And at the current rate, we have about 15 to 25 years before we put that 500 gigatons back into the atmosphere. So what did I learn from this? It's kind of simple. We got to keep it in the ground. We have to keep those hydrocarbons in the ground. Or we got to figure out how to grab them on their way out of a coal-fired power plant and solidify them or liquefy them and then stick them back in the ground, or not let them become carbon dioxide. So I'm a climate scientist. I'm studying the climate models, looking at projections for the future. It's kind of depressing, kind of challenging. Like, wow, we're not making a lot of progress. So I did something that's not super rational, but I wrote a book. Just because, actually, I co-authored a book. So Laura Stick is an environmental food activist in the Bay Area, a chef, and I'm the only climate scientist she knew. So, and she got a $10,000 release from advance from a publisher to write a book. So off we go. So I start studying the connections between food and climate change. The real intention was everyone cares about food. Maybe we can kind of connect food with climate change, and maybe they'll care about climate change. But what it did is actually kind of made me think about my own life. And there's a couple things I'm interested in. I like biking, and I like burritos. In fact, I really like burritos. I created something called the Burrito Enjoyment Index. And I looked at the average American and how much they enjoy burritos, and I compared them with my own. But in investigating burritos, I actually started to look at what's the environmental impact of my interest in burritos, or my eating burritos. And so I did a burrito showdown where I calculated the carbon emissions of a chicken versus a beef burrito to see like the energy required to manufacture and make these things. And I was shocked to find that my simple choice when I go to Chipotle about which burrito flavor, and there's no cost difference essentially, resulted in like a 5 times difference in carbon footprint, in the energy required, or the carbon, and not just carbon, but methane that gets emitted as a result of my burrito choice. And it turns out that if you look at diet and you look at driving, you'll see there's kind of similar differences. You drive a big car, it's got high carbon emissions, more fuel efficient car. It's kind of the same. What we found and what the research we presented in this book was that your diet has a similar impact on carbon emissions as the car you drive. So now what about my bicycle? So how about when I ride a bike? What's the carbon footprint of riding? Not quite 0, because how am I powered? By burritos, thank you. So it turns out that by the choice of burrito, beef burrito versus chicken burrito, affects the equivalent fuel economy of riding a bicycle. So these were some of the stories that we shared in our book. And I wanted to make them light and interesting and engaging, and this kind of led me into a path of interacting with the public. And when we released our book, I gave about 200 talks in bookstores and universities and schools about food and climate change, and try to use humor and fun. But there was one group of folks who were missing at the talks that I gave at the universities and at the bookstores, and those were young kids. And so I took some of the stories that we had created, and I said, how can I present these to younger audiences? And at San Jose State, where I work, I met some wonderful storytellers in the film and animation departments. And they helped me create this Green Ninja superhero, this climate action superhero who actually doesn't talk about the science so much, but just does stuff that tries to make the world more sustainable. And so we created these videos and some animated and live action videos that chronicle the story of Green Ninja. We made a couple games, and we also started running education programs in schools. And this kind of led me from just being like an informal educator into formal education, where we started to go into the classroom. Our Green Ninja show, our videos are on YouTube. We try to use humor and fun to discuss a very challenging and somewhat depressing topic, which is climate change. So we have some music videos, and we also, of course, have burritos featured in there. And so here I am interrogating 2 different types of burritos with my Burrito Meter. And then this is one of the most amazing photos in the history of photography. This is a burrito farm, and I've just pulled out a burrito from, look at those roots of this one, And yeah, this is kind of silliness and fun. And I'm a reluctant actor in these. But our focus is actually much more serious. And our focus looking at children is based on literature that suggests that children can be influencers. For example, in this study, they report that children average a purchase influence attempt every 2 minutes when shopping with their parents. And we can kind of imagine, like some child like pulling on their mom or dad saying, I want that cereal. So there is a strong piece of literature that suggests that children can influence behavior of their parents. And so if they're young kids learning about recycling, they have taken that home. They've also taken home behaviors around litter control in this country. And some of those children turn into be activists who turn into be engineers and scientists at universities. So there's a real track between inspiring and educating young people and what happens to their trajectory in the future. So our current path and what we're doing right now is we're building a middle school science curriculum that satisfies the new science standards that we just heard about, the next generation science standards. but that also our goal is to produce verifiable reductions in carbon emissions. And a lot of people talk about how great education is in terms of like being good for the environment or other social causes. But because we don't quantify things as much because it's hard, we don't see the funding. So Elon Musk is tweeting about solar panels, electric cars, and batteries. And as all great steps towards reducing carbon emissions, we don't hear much about education in that kind of context. And so we're trying, and as well as developing educational curriculum, we're developing something like a Fitbit for environmental education that tracks, using real-time cloud-based data, student engagement in their home and community to determine if their transportation, their food, or their home energy use is changing over time. So these are long longitudinal studies over years where we track students, because we think that unless we can demonstrate actual measurable reductions in carbon emissions, no one will really take us seriously as a viable mitigation measure for doing something about climate change. The opportunity is large. These new science standards have been adopted in 16 states. We estimate that 20 or 30 million kids will be learning science in this new way, and that solving problems around climate change and other environmental issues and other social issues is kind of a central piece of these new science standards. By 2018 and 19, there'll be widespread purchasing of new curriculum in schools. Textbooks are kind of going away, and so we have started a benefit corporation to actually license and sell curriculum in schools. Because when we gave away our curriculum for free, people sometimes don't value free as much. And we found that we really need to go in the marketplace and sell it for them to actually distribute it and use it in schools. And so that's the way we're trying to scale our materials. So the third thing I learned was dream big. And so, don't be shy. Go for it. And speaking of dreaming big, no climate change talk, especially today, especially yesterday and today. Today there's a hearing in the House. Michael Mann, climate scientist, 3 climate change deniers talking about climate science. My friend is there. And we know that our president is not a big believer in global warming. And to make sure that we definitely understand that, we have Scott Pruitt, Rick Tillerson, Rick Perry, 3 basically people who would say they don't believe in the science of climate change. So this kind of hits me hard, me and my colleagues, who some of them have had death threats. We've been in a scandal. Green Ninja has been in a scandal. We got funding from NASA, and they were very critical of NASA giving funding to us. And we got featured in some top 10 government abuses of funding. It's kind of satisfying in a way, but this is a real battle. And so how do we deal with this? And we've heard some earlier speakers talk about like how do you deal with challenges in your own research. Funding goes away. Some of us are going to experience that right now, or other challenges. So for me, in this particular case, my inspiration comes in people, in our democracy. And so in the Women's March that happened the day after the inauguration, in hearing people chant, "This is what democracy looks like." And you live in Berkeley, which has a historical, has a history of social engagement. So on April 22nd, next month, many scientists will walk out of the lab onto the streets as part of the March for Science. And because it's not just climate science that's being devalued, it's the entire field of science. And you saw NIH funding, right? One of the areas that looks like they're going to lose a lot of budget. So for me, I'm going to go to the People's Climate March in Washington, D.C. I'm going to emit a whole bunch of carbon emissions and fly there. I definitely think about that. There is some irony in that. I am going to visit the lawmakers before the People's Climate March. I'm also going to go to National Science Foundation, who was not mentioned in the early Trump budget that was sent out. So we don't know what that's going to mean for National Science Foundation. But what we do know is that if we sit around and don't say anything, then we're going to be a witness to whatever happens. And that if we go out and actually get involved in the process, then at least we're involved. And one of my good friends, who is the guy who's at the House Committee right now, spends one day a week going to Capitol Hill. He works at NASA in Maryland and talks to Republican lawmakers about funding science. And he says they're very interested. They listen to him, or the staffers listen. So the kind of last piece that I have learned is to be strong. This is going to be a challenging time for science. This is going to be a challenging time for us. And not just for science, but in general. Alternative facts. You know, we have to be strong. We have to be present. At least that's what I'm doing. And there is a group called 350.org. They're a group that's working in the climate area. I heard a talk by one of the 350.org people, and it really spoke to me. I was in an audience of mostly young people. He said, I'm not going to suggest that you go out and get arrested, especially if you're young, because you may want to work at Lawrence Livermore in the future, or you may want to go do something. But if you're a tenured faculty and you believe in something, then go get arrested. Because if you look at social movements in the past, you'll see that people had to be, some people had to go out on a limb to make real change. So I'm passionate around education and young people, but I'm really passionate about people in general. And I think we will get through this. And good luck. Thank you.